Well, dear students, in this video I am going to explain you the geometrical meaning of angular momentum. Just I told in case of torque, which component torque cannot produce, which component of force cannot produce torque, like that, and which component of force responsible for producing torque. The same way, angular momentum, we have learnt Lz equal to xpy minus ypx. Elaborating this equation about angular momentum, we will try to understand how the components of linear momentum can be effectively used to produce angular momentum. So here in this figure, a body is constant to move in xy plane. In xy plane. At an instant at point P whose Cartesian coordinates are xy and polar coordinates r and theta. Phi is the angle between direction vector P and x-axis. From geometry, this angle theta, this is phi, this is phi minus theta, it will be also phi minus theta. Vector P, what is the vector P? Linear momentum of body moving on circular path. You know, when body moves on circular path along with the angular velocity, it has linear velocity which acts along tangent. So due to that, it may have linear momentum. And so vector P can be drawn along x-axis and y-axis. Along x-axis component Px equal to P cos phi and Py equal to P sin phi. This angle phi minus theta. Component of P along radius is called radial component PR. R for radial. PR radial component P cos phi minus theta. And along tangent is called angular component of tangential component P theta equal to P sin phi minus theta. Dear students, I have written P like this, small p. Actually, I have seen a student write small p like this. No, it is wrong. Write like this. Small p this. It is in printing in books. Printing of books has this p, but in writing we should write like this. Now from figure. Now we know from concept of torque that we proved Lz equal to xpy minus pypx. Py is the component of linear momentum along y-axis, px along x-axis, and xy are the Cartesian coordinate of point P. From figure, x equal to, in this triangle, base upon hypotenuse cos theta. So it is r cos theta. Nani? Y equal to r sin theta. Px, P cos phi, and Py, P sin phi. While PR equal to P cos phi minus theta. What is PR? PR is called radial component of linear momentum. Now, Py, P theta, tangential component, P sin phi minus theta. Now putting the value of xy, px, py in equation 1, we get, putting the value of xy and px and py, we get Lz equal to x r cos theta. P x py, P sin phi minus ypx r sin theta or P cos phi. I am putting the value here, xpy minus ypx. Lz is the angular momentum along z direction of body which is moving in xy plane. It is P cos phi. P cos Px, P cos phi. Or it is equal to Rp sin phi cos theta minus R sin theta है. Cos phi sin theta. It is sin A minus B. So here LZ is equal to Rp sin phi minus theta. This is equation 2. What is phi minus theta in fact? What is phi minus theta? Phi minus theta is the angle between direction of vector P and position vector of point P. From figure, this is what phi minus theta. This is R. This is perpendicular distance of line of action of P. So from figure, R sin phi minus theta is equal to B, where V upon R equal to sin phi minus theta. So LZ comes out to be B into P. This is one definition of angular momentum. This is also called a moment of linear momentum. Angular momentum, that way is also called moment. When some quantity multiplied by distance, it becomes moment. From this equation we can say that angular momentum of body about any axis rotation, and hence angular magnitude of angular momentum. Angular momentum of a body about axis of rotation is equal to product of magnitude of linear momentum and perpendicular distance and perpendicular distance of line of action of linear momentum. Here I told you now, L equal to B into P, BP. So it does not depend on only P, depend on B, and B depends again line of action. This B becomes 0. B becomes 0 when direction P along radius. And if B 0, angular momentum 0. Means if the line of action of linear momentum passes through axis rotation or point of rotation, then angular momentum of the moving body is 0. This is very important here to know if B equal to 0, it means linear momentum acts along position vector, radius. That is the line of action of P passing through point of rotation. Then angular momentum is 0, like torque is also 0. Kab? When torque 0, when force is there, but that force acting along the position vector, means line of action of force passed through point of rotation, then force is unable to produce any torque. Similarly, the momentum which is acting along the position vector will not have or will not be able to produce angular momentum. This is one meaning. Now, further, from equation 2, there sin phi minus theta equal to P sin phi minus theta equal to P theta. Therefore, magnitude of momentum P equal to L equal to R into P theta. Again the same thing. Now this is the angular momentum. This is R, magnitude R. So it is also equal to product of angular momentum into perpendicular. So which momentum? Component of angular momentum acting along tangent. P theta is this phi minus theta angle between R and P. If phi minus theta is 0, that is direction of P and position vector R. Position vector R are the same, then L is equal to 0. Magnitude of angular momentum will be 0, P theta 0 आपको, by theta phi minus theta 0, तो sin 0 0, so angular momentum 0, P theta 0, L 0. So ultimately, major conclusion here is that if line of action of linear momentum pass through point rotation, then momentum 0, and hence we can say here also that along radius, it is the radial component, and hence radial component of linear momentum does not contribute to angular momentum. It is the tangential component of linear momentum which produces torque. Please remember this thing. So ultimately, geometrical meaning of linear momentum is that no angular momentum will be there if force acts on radius, and for a given position the angular momentum will be maximum if linear momentum acts along tangent. If linear momentum acts along tangent, then for a given position, for a given momentum, around maximum if P is along tangent. Angular component produces angular momentum. Further here, like we have written Lx we have written here कि LZ we have got XPY minus YPX. Similarly, LX will be YPZ minus ZPY, and LY will be ZPX minus XPZ. And therefore, if vector L is a three-dimensional vector having components Lx, Ly and Lz along x, y and z axes, then vector L is equal to Lx I cap plus Ly j cap plus Lz. I hope you are familiar now with I cap, j cap, k cap. These are unit vector along x, y, z axis. Now, I think this should not feel any difficulty. Putting the value of Lx, Ly, Lz here, what you will get? Putting the value of Lx, Ly, Lz, we get vector L equal to YPZ minus ZPY I cap plus ZPX minus XPZ J cap plus XPY minus YPX K cap, or finally L equal to, here it is in fact IJK, यानी कि it is X, Y, Z, PX, PY and PZ, which is equal to X I cap plus Y J cap plus Z K cap cross क्या भाई cross PX cross product. I am coming to a very general definition. PX I cap plus PY J cap plus PZ K cap. This is cross product of this vector R cross P. So most general definition of angular momentum is that L is equal to R cross P, and direction of R cross P will be at right angle to the plane containing R and P. Just like in this diagram which we have drawn here, XY body is rotating XY plane. So linear momentum is in XY plane. R is also XY plane. So vector L will be along Z axis, perpendicular to both. So angular momentum is axial vector. है ना? Vector L is an axial vector. Please try to understand what I say. The body of mass m is moving on circular path. This circular path here, and the circular path is xy plane. Body rotating like this. Here P is like this. Okay? This is R. So R cross P, R cross P will come outward. So L, direction of L will be outward like this. But we can't draw line here, so we show this line like this. So vector L will be at right angle to the plane of circle. Here plane of circle is in xy plane. So L is along Z axis. So remember that So if it is body moving anti-clockwise, air will be outward clockwise into. It is very important to understand here. Vector product, very important, dear students, to understand mechanics as well as so many things in class 12. You will get very good application of vector product. I've seen my video about vector product. There are smallest number of views on definition of cross product and application. Please see that. See the video including which have their definition of cross product and scalar product. Very important. Like it is like if you don't know counting, you can't learn arithmetic. Thank you. In next video, I will be telling you something more about physical meaning and law of conservation of angular momentum. Thank you.